Welcome everybody, this is Mac and I'm here to talk now about factoring. This is the first factoring video that I'm making, and so in fact I'm going to break this really down. I am going to go slow, I'm just going to let you know that, but you're going to get it if you follow along. So invest the time, I'm going to get you there, I promise. You're going to feel great about factoring by the end of this. A lot of students, this is where they fall apart, but there's no reason to. I got you, I'm going to help you. Remember to go to Mac's Tutorials, and I have, again, many videos on how to factor, and I go very slowly. I might be going too slowly on this one, but I think it's okay. What we're going to do is we're going to just pull out numbers. I'm not even going to worry about letters and variables for this entire ABC sequence of the next three videos I'm going to do, okay? And then I'll do another one. We're just going to do letters, and then we're going to combine them. We're going to really break this down. And here's what I mean by this. The first time when I say factor something else, and factor basically means we're going to divide things out. We're going to find out what things would after we divide them out, we could multiply them back to get this. I know that's a little confusing. Let's just do some. I'm looking here at number 1, and I'm trying to find a number that will go into both 6 and 12. Can you think of a number that will go into both 6 and 12? And what I'm asking what's the same? And so I call this one the what's the same. And so you go, well, 6x and 12, what's the same? And the answer is 6. 6 is the same between both of those. Then I'm going to write parentheses, and then I'm going to say what's left over. Okay, and so if I pull a 6 out of the 6x, what's left over? Just the x. I'm going to write the plus sign. If I had 12 and I pulled out 6, what's left over? And remember, we're dividing. Don't subtract, we're dividing. And the answer is 2. Now, how do I know if I got the answer right? Well, now go like this if you want, and you would see we would get 6x plus 12, which looks like the original. So that's how you would check it at the end. But my answer is 6 parentheses x plus 2. Let's look at number 2. Can you think of a number that will go into 15 and 25? That's usually the trickiest part if you don't have your multiplication tables down. Okay, and the answer is 5 will go into both of these. Now, what's left over on the first? 3 and the y. We didn't do anything to that y. That y is still left over. The minus sign stays. And what's left over after I pull a 5 out of 25? And the answer is 5. Remember, we're dividing. And you can always distribute and find out we're going back. So do you see how this is just backwards distributed property? Now watch. I'm going to make a mistake on 3 and watch what happens. I'm looking at the 8 and the 20, and the answer is 4. 4 goes into both of these, right? But I don't see it right away. And so I'm just going to pull out a 2. And so I pull out a 2. What's left over? In the first, it's a 4a. What's left over in the second? Plus 10. It's not wrong yet, okay? So what you got to ask yourself is, once you do that, then say, is there still something that's the same? And I look at it and I go, oh yeah, there's another 2 I could pull out, right? And so what you do is you pull out another 2. And so once I pull out another 2, that's actually going to be a 4. And what happens to the 4a when I pull out 2? It becomes a 2a. What happens when I pull out a 2 out of the 10? It just becomes a 5. Now, of course, you could have gotten there by just seeing the 4, but I'm just trying to show you what do you do if you don't see it right away. Pick something, pick anything, and then ask yourself, well, is there something left over after you do that? And there could be. All right, let's go on to number 4 here. Between 14 and 35, I see that a 7 will go into both. So what's the same? 7. What's left over? 2m and the minus sign. Always keep the sign. What's left over? 5, because I'm dividing. Next one, 18 and 24. I hope you might pull out a 2 or something, but at this point, I'm really hoping you see the 6, okay? And when I do that, what's left over? A 3p. And what's left over on the second? A 4. Remember, we're dividing, we're not subtracting, okay? On number 6, 21 and 49, I hope you see that that's going to be a 7. And when I'm left over, I'm going to get a 3b minus, and what's left over on the second one? A 7. Number 7, what goes into 30 and 45? You probably see right away a 5. Great. Pull that out, and what's left over on the 30? And the answer is 6r. And then I'm left with a plus 9. Now stop. Don't just be done. Look at the parentheses. Did you see something else? Oh my goodness. 6 and a 9. You know what? I could have also pulled out a 3. And so really, at the beginning, you could have seen 15 I didn't, or we didn't. So, that's fine. We did that. But now when I pull a 3 from 6, I'm left with a 2r. And when I pull a 3 from the 9, I'm left with a 3. And so this is really my answer right there. Okay, so this answer right here, would that be wrong? Yeah, it's not fully factored. Okay, so when you have your what's left over, you should be able to pull nothing out of that. Okay, so let's take a look at number 8. What will go into 16 and 40? Maybe you see 4, maybe you just see 2. I see an 8, okay? And I notice that out of the 16, that becomes a 2k minus, and 40 divided by 8 is going to be a 5, and I'm done. If you pulled out a 4, that's fine, but then you may have had some work to do after. So always check your answer to see if there's more you can go. Number 9, can I pull out a... now, another way to do this, start with the lowest number, which is 12. Will 12 go into 18? No. Well, what's your next factor lower? What's the next lowest number from 12? 11, no. 10, 9, 8, 7. You'll probably get the 6. Will 6 go into 12 and 18? Yeah. So when you're starting to struggle and it's not very apparent, start with the lowest number and then just keep going down factors that go into the lowest number. Okay, so this one will be a 2t and then a plus, and that's just going to be a 3. Let's look at number 10 over here. Okay, will 28 go into 56? Well, you know what? It actually will. Okay, so here I can pull out a 28, and I'm going to be left with, the number is gone, so what do I write? I'm going to write a C, because 28 times divided by 28 is really just a 1, but we don't write the 1 in front of the number, right? And so that's really just my answer. Okay, number 11, will 32 go into 48? No. Well, what's my next lowest, what's my next number? Well, if you go 32 over here, so, obviously we have 1 times 32, then we have 2 times 16. So will 16 go into 48? It actually will. It'll go in 3 times, so 16 can be your answer. Let's pretend you don't see it, though, and you just saw an 8, because most of you will see the 8 right away, right? You're going to get a 4n plus 6. Cool. But now look at the leftover. You could have gone more. You could have also pulled out a 2. So when I do that, let's pull a 2 out of this, and I get 2n plus 3. But you can see that you could have done 16 right away had you seen it. Okay. Now, obviously, you want to see it and feel good about your multiplication tables to see it right away. But if you don't, there's some options for you, right? When I see 27 and 63, my brain just goes 9. And I'm going to get a 3q minus, and what's 63 divided by 9? That's going to be a 7, and I can't pull anything else, so I'm done. Okay, this one, 50 and this is 75. The first thing my brain sees is the 5, and you probably do too. But because I used to play like video games in the 1980s and we would use quarters, I see 50 and the 75. I like Donkey Kong. I was like all over that thing. Pac-Man, all that stuff. Miss Pac-Man, I was really good at Miss Pac-Man. But anyways, so you'd put your quarters in, and I see 50 and 75 immediately as being divisible by 25, okay, because of money. Now I pull out a 25, and that leaves me with a 2w plus 3. But again, if you only saw the 5, that's okay. You can look up to like an example like this to see how you can keep going after you do your first one, and you can keep taking that down. 24 and 60. Well, the first thing my brain sees is the 6. I do know that there's a bigger one. 12 will go into both of them, but let's just say I only saw 6 because we should practice these. And you get 4d minus 10. Look at what's left over. I can pull out another 2, and I get 12 parentheses 2d minus 5. Okay, let's keep going. Let's do this one, 36 and 54. Well, let me do it a different way. Will 36 go into 54? No. Well, what's the next biggest factor of 36? Well, that would be 2 times 18. Will 18 go into 54? I can do it in my head and know that the answer is yes. If you can't, then go ahead and do the biggest number you see, which is probably 6, and do it on one of the, like a compound one like we did before. But here, I'm just going to pull out an 18, if you don't mind. And that's going to leave me 18 goes into 36 2 times, and 18 goes into 54 3 times. Okay? Let's go on to number 16, 42 and 70. Well, the first thing my brain sees is a 7. I can tell right now that there's going to be another one, but that's what my brain sees. So I'm going to just pull out the 7, and I'm going to go 6j minus 10. Now I'm going to look inside and go, oh, wait, I could have done another 2, couldn't I? I don't know my 14 times tables. You're not expected to. So that's okay. So just do it twice. You know, we could do a whole thing about finding the greatest common factor, and I can go 42, and I can go 1 times 42, and then I can go 2 times, oh, what is that? You know, 21, and I can go 3 times 14. Hey, I found it. And we could do the greatest common factor, and we can do that. But I think that just going here and checking and then going here is actually a quicker way to do it. So you do what you like. I do see this one right here, and I realize that 9 can go into this one because I do have my multiplication tables up to 12 pretty good. So 9 here, and I'm going to be left with a 9v plus, and 9 goes into 108, 12. But I could have gone bigger. I could have pulled out what? I could have pulled out another 3, couldn't I? So 3 will go into 9 and 12, so I'm going to pull out another 3. And when I pull out another 3, that's going to be a 27, and I'm going to be left over with a 3v plus 4. Are you expected to know your 27 times tables? Of course you're not. Okay, so that's why doing it that way works a little bit better. 18, the first thing that pops into my head when I see this is 5, so I'm just going to do that. And when I divide that out of 20, I'm left with a 4z minus 9. I can't do anything with 4 and 9, so I leave it alone. We're going to go on to number 19. I see a 7, 7 parentheses, 2f plus 4. But guess what? I'm looking at my 2f and my 4. I could have pulled out another 2. 14f plus 2. Had I slowed down and really thought about it, I would have seen the 14, but my brain immediately saw the 7 and I went with it, okay? And you can see that that's fine as long as you check your answer and realize that there was more to go. This one, 48 and 72. Okay, I see 24 going into these. You're probably not. So what are you going to see? You might see the 8 going into it, okay? So if I go 8, what's left over? I'm going to have a 6g minus 9. But then I'm going to look at my 6g and 9 and go, hey, I could have gone another 3. And you're going to get 24, and you're going to be left, what happens when I pull a 3 out of 6? 2g minus 3, because I pulled a 3 out. So I hope that, you know, obviously this all has to do with how well you are with multiplying in your head and knowing your multiplication tables. But if you see that if you just, you know, if you look at some of these examples where I did it twice, you don't even have to, okay? You could just do it once and then just check your answer and do it twice. Well, there's A. Let's keep going. I'll see you on B.